Okay, uh, in our previous video we already implemented the simplest binary search tree operation, which is checking if the binary search tree is empty or not. It's a simple operation because it's just a matter of checking if the root is null or not. If the root is null, that means our binary search is empty, otherwise our binary search is not empty. So in this operation, in this video, we'll implement another method, which is a method which can add or insert a node to a binary search tree. And let's directly dive into the implementation. Okay, this is another inserting a node to a binary search tree. Okay, inserting a node to a binary. Here there are two main keys: inserting a node to an empty binary search tree, and the second one is inserting a node to a non-empty binary search tree. Okay, this is inserting a node to an empty binary search is a simple operation. It's just create a new leaf node and assign it as a root. Here there are some steps that you gotta follow while inserting a node to an empty binary search tree. The first step is create a new leaf node. Well, both is right and a leaf node is both is right and left child are null. There is no reference to right and left child. Okay, first we create a new leaf node, then find the right parent for a newly created leaf node, then finally attach the newly created leaf node to its parent. Okay, first we create a new leaf node, then find the right parent to a newly created leaf node, then attach the newly created leaf node. Here we will traverse here while finding the right parent for a newly created leaf node. We are required to traverse through the tree starting from its root. Okay, we'll traverse through the tree starting from its root. Then let's implement this. Let's set this return type to null, and let's name it insert, and let's only accept this the key of the node that we're going to insert. Okay, let's first implement inserting a node to an empty binary search tree. A node to an empty binary search tree. To check if the binary search tree is empty or not, we can use this operation, this is empty operation, or we just can check if the root is null or not. If the root is null, then that means our binary search is empty. If this is the case, this root will be set to the newly created BST node, then this one. Okay, we'll set it to this newly created node. Otherwise, inserting a node to a non-empty binary search tree. Else, which is, let's first create a new leaf node, bst node new node bst node. Then we'll pass the key. We just created a new leaf node with a key, with a given key. Then let's find the parent to attach, find the parent, the right parent for newly created leaf node. Okay, to do that, let's start traversing from let's start traversing from this route. Let's start traversing from this route, and let's set our parent to null. Okay, then while our temp is not empty, is not null, we'll set this parent will be set to this temp. If temp dot key less than the key value of the node that we want to insert, then temp will be updated with the right, this temp will be updated to temp dot right. That means we are inserting our node to the right of our tree. Otherwise, temp will be temp dot left. Okay, now this will give us the parent, the right parent for our newly created leaf node. Then finally we'll attach this attach the newly created leaf node to its parent, Okay, now let's if parent dot key less than key, which is if the key value of the parent is less than the key value of the node we want to attach. That means parent dot right, this new node will be attached to the right of the parent, will be this newly created node. Otherwise, parent dot left will be this newly created node. And this is it. We check if our this is the insert operation in a binary search tree. First we checked if the binary search is empty or not. If it's empty, we just created a new node and assigned it as a root. Otherwise, we create a leaf node, then we find the right parent for a newly created leaf node, and we attach that newly created to its parent. This is it. Now let's test it from a test class. Let's create a new test class called test bst java. Then okay, let's name it testing basic binary search 3 operations. With the first one, testing EasyMPT. The second one, testing insert. Okay. Test BST. Now public static void main. BST. We just created an MPT binary search tree. Okay, then checking if the binary, the BST is MPT or not. Checking if the newly created binary search tree is MPT or not. This is creating an MPT binary search tree. Let's just, now we just declared or created an MPT binary search tree. Then let's check it. Node all dot print line is the BST MPT. Okay. Okay. Yeah, the BST is empty, the binary search tree is empty. Let's now check. Okay. Okay. Inserting a node to an empty binary search tree base dot insert. Let's insert 7 and let's check if the BST is still empty. Okay, now let's insert a node to a binary search tree, an empty binary search tree, and check if the BST is still empty or not. It's not empty anymore. Okay, now we're almost there. Let's finally BST dot. Okay, and now inserting a node to a non-empty binary search tree. BST dot insert. Okay, let's insert 4 now. Okay, now let's check this operation. Working. Okay, now we're done with this then we'll insert to a binary search tree, to a binary